4.2 Wildcard masks in ACLs. A wildcard mask tells the ACL which bits of the IPv4 address must match and which bits can be ignored. The most important rule to remember is that 0 means check or match, and 1 means ignore. This is the opposite logic of a subnet mask. Here we have the examples of the wildcard mask. The first one, the wildcard mask, is 0.0.0.0. Let's take a look at the last 0, which is the last octet. Convert that decimal number 0 to the 8-bit binary, we get 00000000. The meaning is match all bits, match all octets. The second one is 0.0.0.36. The last octet, which is the 36 converted to 8-bit binary, is 00111111, which means match the first 3 octets and then match the 2 leftmost bits of the last octets. For the remaining 6 bits in the last octets, ignore them. The third one, we have 0.0.0.15. For the 15 and converted to 8-bit binary, we have 00001111. So the meaning here is match the first 3 octets, also match the 4 leftmost bits of the last octets, ignore the last 4 bits of the last octets. The fourth example, we have 0.0.0.252. If we convert that 252 to binary, we get 11111100. The meaning for here is to match the first 3 octets, ignore the 6 leftmost bits of the last octet, and match the last 2 bits. In the last example, we have the 0.0.0.255. We convert the 255 to the octet, it is 11111111. The meaning here is match the first 3 octets and ignore the last octet. Using wildcard mask will take some practice. Refer to the example to learn how the wildcard mask is used to filter traffic for one host, one subnet, and a range IPv4 addresses. In this example, the wildcard mask is used to match a specific host IPv4 address. So the IPv4 address is 192.168.1.1. The wildcard mask is 0.0.0.0. Remember, 0 means match and 1 means ignore. So we need to match all the bits. Convert the numbers into binary form is much easier to see. So as you can see on the right hand side, they are the binary equivalent. The blue number, the text, the number in blue, is the IPv4 address. And then the color in orange, that's the wildcard mask. So all the IPv4 bits need to be matched, so the answer should be the same. So the last row, permitted IPv4 address, we get the same result. Same bits, therefore same decimal. That is 192.168.1.1. Let's take a look at the second example. The IPv4 address is 192.168.1.1. Its equivalent binary is on the right-hand side. And then the next row shows the wildcard mask. In this example, the wildcard mask is 0.0.0.255. Its equivalent binary number is showing on the right. So all the 0 bits means those are the bits need to be matched. I color them in orange. 1s means ignored. So the last row, permitted IPv4 address, as you can see, they are here. So we basically take all the matching bits, the one in blue color, and then copy and paste in the last row. So the leftmost 3 octets are completely the same. For the remaining octet, the 8 bits can be any number in the range. However, there are reserved bits. All the 0 bits are not allowed to use, and all the 1 bits, which is 255, that's for broadcast domain. So the only available IP addresses are excluding all 0 and excluding all the 1s. In terms of decimal, it's excluding 0 and 255. So we pick 1 all the way to 254. So the permitted IPv4 address range is between 192.168.1.1 to 192.168.1.254. The last example here shows IPv4 address is 192.168.16.0. Its equivalent binary number is on the right. The next row shows the Wildcard mask with 0.0.15.255 with its equivalent binary number. And then the last row shows the permitted IPv4 address. Same as before, let's look at the must match bit, the one in orange. So these bits, there are 20 of them. So the IPv4 address, the blue bits, need to be copied and pasted into the last row. These are the must match bits. And then the remaining 12 bits can be any number. Can be 0, can be 1. They don't need to be matched. Can be ignored. So it's between 0 all the way to 1 or 1, 1, 1, 1, followed by 1, 1, 1, 1, 1, 1, 1, 1 in this case. So convert these numbers into decimal. We have 192.168.16.1 all the way to 192.168.31.254. Same reason as before, all 0 bits for an octet and all 1 bits are reserved. 4.2.3 Wildcard mask calculation. Calculating wildcard mask can be challenging. One shortcut method is to subtract the subnet mask from 255.255.255.255. Refer to the examples to learn how to calculate the wildcard mask using subnet mask. 4.2.4 Wildcard mask keywords. The wildcard mask keywords are host and any. Cisco IOS provides 2 shortcuts that make ACL commands easier to write and read. The host is 0.0.0.0. It means match one specific IP address exactly. And any is 255.255.255.255. All wildcard bits are 1, so all address bits are ignored. Therefore, any IPv4 address matches. These 2 sets of ACL commands are equivalent. Using wildcard masks, access list 10 permit 192.168.10.10 0.0.0.0. Also, access list 11 permit 0.0.0.0 255.255.255.255 with ACL 10 permits only host 192.168.10.10. Also, ACL 11 permits all IPv4 addresses. The Cisco iOS provides shortcuts. You can use access list 10 permit host 192.168.10.10. Access list 11 permit any.